Hello everyone, welcome to SQL Bits. My name is Rukmani Gopalan. I'm a product manager on the Azure Data Lake Storage team at Microsoft. Today, I'm going to be talking to you about designing scalable and performant data lake architectures on Azure Data Lake Storage. Hope you enjoy the talk. Welcome to this session on designing performant and scalable data lakes using Azure Data Lake Storage. Why is this topic important today? Data is growing at a rate that's faster than ever before. There is a study that showed that by the end of this year, every human being on this planet is going to generate 1.7 megabytes of data every second. That is how rapid the proliferation of data is. And this kind of data has now become crucial for businesses to start gathering and gleaning insights from, to not just help understand how their businesses are doing, but also really play a critical role in transforming their business itself, whether it is how they engage with the customers or what new features they build in their products, or in some cases, what new products to build as well. Critical to solving all these needs is having a clear and clean data lake strategy that helps meet the performance and scale requirements of all these businesses as the data and the scenarios that rely on data continue to explode. And that's what we're going to be talking about in this section. I've divided this talk into 3 sections. In the first section, we'll be talking about the concepts of what a data lake based strategy looks like and some of the architectural patterns that we see supporting a data lake strategy. In the second section, we're going to be delving into a lot of details that go into designing your data lake, including how do you set up the data, organize the data, secure the data, and do all this in a cost-effective fashion. In the final section, we're going to be looking at strategies to optimize your data lake to achieve the best performance and scale while retaining the same cost effectiveness. So let's get started. What you see here is a traditional on-premises analytics pipeline using a data warehousing approach. The design of this pipeline always starts with a question or a business problem to be solved, and that dictates what kind of data needs to be gathered. And this data is highly structured and typically resides in various sources that are operational databases or relational databases in online transaction processing systems. This data undergoes transformations using ETL processings, and it is loaded into a central enterprise data warehouse. And from this point on, it goes through yet another set of transformations for downstream processing into various BI pipelines that are important for your scenarios for either business reporting or exposing this data for business analysts. A key theme that you will see across an on-premises based analytics pipeline using a data warehousing approach is the data that you rely on is highly structured, or it needs to be highly structured. This might not be the case anymore. And what you also see is throughout the various stages of your data processing, depending on the kind of processing you do, you identify a separate data store for that, creating what we call as data silos. These data silos and data movement across the different silos introduce a lot more opportunity for error in your data processing pipeline. And in addition, duplicating this data back and forth across different systems also increases the cost of your system. And finally, in an on-premises infrastructure, when you think about provisioning the relevant resources and planning the capacity, you always plan for peak utilization. So if you're running monthly reports, even if your systems are not going to be used for, 25 days out of a month, you'll have to provision these hardware resources and keep them around. And when you think about bursts in demand, say seasonal demand, such as during the holiday season, you got to anticipate all that in advance and provision your resources to meet the peak capacity needs, and you design for peak utilization. Now let's see how a modern data warehouse approach on the cloud helps you address these needs. And I'm going to be talking about a modern data warehouse implementation on Azure. The premise of a modern data warehouse approach is you have a data first strategy instead of starting with the business problem. So here you identify data from various sources, whether it is, social media data or logs from your other systems or dump of data from your LOB systems. You make no assumptions about the structure or the semantics of the data and focus on ingesting them in their raw natural state into a data lake storage. In this case, it is Azure Data Lake Storage. Once you have ingested the data, depending on the business problem that you want to solve, you now apply schema on demand on this data, and you work on a set of transformations to extract high value insights from this unstructured data. Typically, the engines used here are Azure Databricks or Azure HD Insight, and now we have recently introduced our newest offering, which is Azure Synapse Analytics, which is essentially your end-to-end modern data warehouse implementation on Azure. That gives you a single pane of glass experience across all these layers. We have a lot of sessions coming out on Azure Synapse Analytics and SQL Bits as well, so please do make sure to check them out to learn more about Azure Synapse Analytics. And coming back to our architecture, once you have extracted this high value data, you then use that to serve that to your downstream BI pipelines. Few key differences. One, you are making no assumptions on the kind of data, whether it is the structure or the size, and you're just ingesting them in their raw natural state. So you're not bound to restricting your business scenarios only on what kind of structured data is available. Second, in a modern data warehouse architecture, you are decoupling the compute needs from the storage needs so you can scale them independent of each other. And any cloud-based resource works on a consumption model for pricing. So you're only paying for the resources that you use. And when you're not using those resources, you're not paying for them. And last but not the least, what you see here in this architecture is throughout the various stages of your pipeline, you are storing data into a central data lake, which is the Azure Data Lake Storage, eliminating these data silos that we talked about. And having these central data lake storage is key to implementing any data lake-based strategy where you have one data store to meet all your needs and you don't worry about creating different data stores for different parts of your pipeline. In addition to implementing a modern data warehouse on the cloud, what this kind of a strategy helps you do is extend the scenarios beyond traditional BI pipelines and business analysts that help you and your business understand how the business is doing, but you also are able to offer more advanced patterns. And that's what we'll be looking at in the next two slides. The next pattern is what we call as the advanced analytics pattern. And here, very similar to the modern data warehouse pattern, you make no assumptions on the kind of data that's coming into your system. You ingest the data into your data lake storage. You do your ETL processing that's traditionally Hadoop or Spark based and extract high value insights. And these insights, in addition to serving them to your BI pipeline layer, you can also feed them to an operational data store such as Cosmos DB back into your applications. So your applications can now behave depending on what insights they've gotten. A classic example, think of this like a recommendation engine. The next pattern that we'll see is what we call as real-time analytics, or it is also referred to as a Lambda architecture. We talked about a pattern where data is ingested from various sources. This is typically done in a batch fashion. So you will be spinning up pipelines to go move the data in a periodic fashion. And that periodicity can be typically a few hours or even nightly or once a week even. With the real-time analytics pattern, in addition to this kind of a batch-based layer, you also have a speed layer where data is streaming from real-time sources, such as your IoT sensors, into the data lake instantaneously. And typically, this data from that's real-time, that's getting streamed in, goes through an ingest layer, that's typically a message broker, and there is some kind of a micro-batching done to do some small aggregations and ingest the data. The idea here behind the real-time streaming pattern is speed to insights. Now, what this lets you do is You can get your dashboards updated almost in real time, depending on what kind of real time insights are coming in from your data. And in addition, you can do a combination of data and data processing done in your speed layer, which is your real time layer, and your batch layer, to combine them into offering much powerful insights that you would not have had otherwise known about. That is the real-time analytics pattern. Now, the key to implementing all these patterns on Azure is to have a central data lake storage that supports all these needs. And that's what we'll be talking about now. What is Azure Data Lake Storage? Azure Data Lake Storage is a no compromises data lake. Our promise is to deliver a secure, performant, and highly scalable storage layer for analytics needs that also brings the cost of ownership of the entire big data pipeline down for the customer. And we'll be talking about some of these characteristics in the rest of this slide. What do I mean by an analytics data storage? What kind of characteristics that it needs to have? First and foremost is scale that we've talked about, right? Regardless of whether you're implementing the modern data warehouse pattern or the advanced analytics pattern, or you're doing the real-time analytics pattern, the key here is to have a central data store, and that central data store supports any kind of workload on any kind of data. So from a data lake storage perspective, we do not impose any limits on what kind of data is stored or what kind of transactions are done. And our customer promise is to meet the customers where they want in terms of what limits we need to support. And in addition, Azure Data Lake Storage is available in all Azure public regions. So depending on what region you want, you can pick and create an instance of Azure Data Lake Storage in that region. Second, when we talk about big data, the big part really leads to an administration challenge for data administrators. As your data continues to grow, managing the data becomes a very key challenge, and Azure Data Lake Storage provides a lot of features with respect to tiered storage or automated lifecycle management policies to help your data administrator manage the data. The third characteristic is performance. As we talked about, getting your insights as soon as possible is key to any business. And from a data lake storage layer perspective, what we have is a built-in file and folder hierarchy with a hierarchical namespace built in to Azure Data Lake Storage. And this file and folder hierarchy helps you make atomic operations, especially for directory operations such as renames or deletes, almost instantaneous, that would have taken a long time in other object storage systems. Microsoft takes its enterprise security promises very seriously, and Azure Data Lake Storage is no exception to that. We have a layered security approach that we'll be talking about further into the presentation as well. And the key here for a layered security approach is to provide various controls and capabilities for the data administrator to control what systems will be able to talk to the storage layer, who will be having the right level of access to what data in the storage layer, and some of the key guarantees around getting the data at rest guarantees around data at rest as well as data in transit. We want to be able to deliver all these capabilities in a cost-effective fashion for our customers. So in addition to various features that help customers manage costs, such as data lifecycle management policies, and also having very competitive pricing for our product itself, one of the key value propositions I do want to call out here, and we'll be talking about this in more detail in the optimization section as well, is the key investments that we make with respect to scale or performance, also by design, help lower the cost of running the data lake itself. And finally, no storage system exists by itself. One key value promise for us is to keep it integration ready. So we have a great relationship with our analytics partners, both within Microsoft as well as the rest of the big data ecosystem. And Azure Data Lake Storage is highly optimized for Spark and Hadoop-based analytics engines. Now, how does this all work? Let us take into consideration how the Azure Data Lake Storage is able to meet the analytics storage needs for our customers. The way Azure Data Lake Storage or ADLS is built is there is a common blob storage foundation that we have on Azure that's existed for almost as long as Azure has existed. And this foundation gives you the basic storage layer that can scale to, our largest customer needs, who are not just running analytics, but a huge variety of other workloads. And it also builds a lot of key features to help manage the data itself, including tiered storage and lifecycle management policy, integrated security capabilities, as well as high availability and disaster recovery offerings with various redundancy models. Now, on top of this common blob storage foundation, we also have specialized protocol layers that are highly optimized for the kind of workloads the customers are running. Our traditional object data store API layer, or the blob API layer, is typically used for backups or archive storage or app development scenarios. We also recently introduced a preview of our NFS v3 protocol layer that's highly used for HPC or high performance computing scenarios, and also compatibility with legacy applications that do want to bring data to the cloud, but they'd be able to talk only the NFS protocol. And now the protocol layer of interest for this talk is the ADLS API that's highly optimized for analytics data. With our native file and folder hierarchy with hierarchical namespace and a protocol layer that's highly optimized for analytics that are traditionally Hadoop file system based, such as Hadoop or Spark, we're able to deliver capabilities on top of these core common blob storage foundation that are highly optimized for analytics storage. So in summary, a data lake architecture relies on a data-first approach. You store high volume of data without imposing a restriction on the structure of the data. And depending on the business problem you want to solve, you defer the work to schematize the data or apply a schema on the data. And you do a lot of processing, which is of ETL, what we call as ETL, extract, transform, and load, to extract high value insights from this unstructured data. And these high value insights are very critical in delivering intelligent business scenarios for you. With that context in mind, let's go into the details of the various considerations of designing your data lake. So as a product manager on the Azure Data Lake Storage team, we have a lot of customer interactions that we're part of, and these customers are in various points in their data lake storage journey. Some of them are just barely thinking about a data lake design. Others are, thinking about modernizing their data warehousing pipelines or existing data lakes into adding more scenarios. And our most popular segment that we very commonly see are customers who have their existing big data processing pipelines on-prem, and they want to migrate their on-prem infrastructure into the cloud and take this opportunity to also modernize their data lakes. And we have special programs to do this. Don't forget to ask us about this. Regardless of where the customers are in their journey, most set of questions are common to all these customers, which is, how do you set up your data lake? How do you organize the data within the data lake? How do you secure the data? And how do you manage the cost? And we're going to be looking at these questions in greater detail in this section. Let's talk about the first question, which is, how do you set up the data lake? Before we start thinking about a setup, let's first take some time to understand how organizations are typically structured. There are individual business units, and then there is a central data platform team. Now take Contoso.com, which is a fictitious organization, as an example. They have HR departments, marketing departments, finance departments, and sales departments, and all of them have their own data that they want to bring to the table, and they also have their own data needs as well. And there could be scenarios where finance department could want sales data, and sales department could want HR data, and so on. And typically, you also see that the organization has a central data team, which is typically called as the data platform team or the data infrastructure team, and they are responsible for the data lake strategy of the organization. If you see this central team, which I'm going to call as the data team for the rest of this talk, is not very big, right? It's a pretty lean team that needs to scale to the needs of the organization. So when we think about a data lake approach, the central data team often wonders if we need to go with a centralized implementation or a federated data lake implementation. What do I mean by this? In a centralized data lake implementation, the central data team owns the data lake strategy. They own the requirements in building out the data lake architecture. And in addition, they are also owning and running the central data lake team for the organization. And depending on how the different business units requirements are, they provide access to the data, relevant access to parts of the data lake, depending on the business needs. And in some cases, they also do the work of ingesting the data and doing the data processing for these various business units. That is a centralized data strategy. In a federated data strategy, this lean central data team owns the data lake architecture, and they also own the key requirements and defining what these requirements are and how they need to be implemented. And based on these requirements, they create what you call as a blueprint. And this blueprint typically has a data lake storage and its associated configurations, like what kind of encryption or what kind of firewall rules and what kind of RBACs need to be set. And they also have corresponding requirements to their compute platforms as well. Once they define this blueprint, when a business unit comes in wanting and having data needs, they stamp out an instance of this blueprint over to the team. And from that point on, the individual business units end up owning and running and operating their data. With respect to what kind of strategy is good for you, the answer is, from a platform perspective, both of these are fair game. All the Azure platform and products support both a centralized or a federated architecture. And what is key into deciding what works for you is determining what kind of resourcing you have in your central data team. Can you scale to all the business needs? And also, key result is, are the individual business teams equipped to own and run their individual data lakes as well? And depending on this, you would choose either a centralized or a federated implementation. Let's take some time to talk about a very special case of this, which is a regional isolation. So organizations with a global footprint have what we call as global data lakes. And within this global data lakes, there is a set of data within every region that is data specific to that region, and the data cannot leave the region. Say, for example, they need to meet some key data sovereignty requirements. And there is another set of data where there's a lot of use in sharing these data and insights with the rest of the organization. So you are kind of building a federated model by design here, where your boundary of federation is on a per region basis. And within every region, you have data lakes that have region specific data that's never shared outside the region, and you have data that's shared across regions. And across this global footprint, the central data team continues to manage the infrastructure and deployment and other governance requirements as well. One key point to note here is, when I say data lake, think about this as a logical data lake, not individual storage accounts or containers that we would see in the next section, but this is a logical data lake that we're talking about. And the centralized or a federated strategy hinges upon who manages and how this logical data lake is structured and who manages what component of the data lake. A quick set of recommendations here. When you are thinking about your data lake architecture and provisioning and deployment and deploying, definitely think about isolating your development, pre-production and production data lakes. And identify what kind of data you have and what resources are there in both the central team and the individual business units, and what the management needs are before defining whether you want to go with a centralized or a federated approach to your data lakes. And these requirements will also design what kind of boundaries your federated data lake approach needs to have if you choose that path. It could be at a business level or at a regional level or some other boundary that you see. The last and final lesson is probably what we learned in kindergarten, which is sharing is goodness. Regardless of what kind of approach you choose, highly promote sharing of data, of course, within the compliance and requirements of your businesses across business units. Otherwise, what you would end up typically seeing is business units duplicating some of the data ingestion and data processing that could have otherwise been optimized by just sharing the data as well. Let's move on to the next section, which talks about how you organize the data within the data lake. When we think about big data, we already talked about how we impose no restrictions on the structure of the data or how the data is organized. This poses a problem of, hey, then there is so much data. How do I end up even managing and organizing this data, right? So let's talk about that. Regardless of the kind of data you process, what you typically see in a big data processing system is data goes through a certain life cycle. In the first layer, you have the raw data, where data is ingested from various sources into the raw data lake. And then these raw data is then cleansed or prepped for further processing. What do I mean by this cleansing or prepping? First, you're defining a structure or you're applying a schema on demand. And then what you're also doing is you're making sure that the data is adhering to the schema and semantic structure. And you're also, in addition to validating the data to meet the schema, you're also thinking about cleaning up the data and what you do with the data that does not meet these structural guarantees. One option, you go ahead and remove the data from your data set, or you fill it with default values. And this data is basically what we call as the enriched data. This enriched data is then transformed or aggregated or joined with other sources to create your high value data, that is the curated data that is used for your downstream processing. These are what we call as data zones. And in addition to the raw, enriched, and curated data zones, you also have workspace data. What is workspace data here? So typically, the raw, curated, and enriched data is all planned data processing that's typically done in a scheduled job fashion. And then you have your exploratory data analysis, which is your data scientists or your data developers looking for the next set of processing to get the next set of insights. Think of these workspace data as scratch pads for these data developers or data scientists, where you provision a workspace zone in your data lake that's kind of your playground for the rest of your data developers and data scientists. These zones form a natural hierarchy into organizing your data lake. And within these zones, you can also have the next level of organization by, say, domain levels or team levels or any other criteria that you work on. Now, let's tie this in with how the hierarchy of data organization happens in ADLS or Azure Data Lake Storage itself. At the highest level, you have a storage account, which is an Azure resource you provision that contains data objects. Within a storage account, you have containers. Containers think of them as a unit of organization, and you can also apply certain levels of access controls or authentication mechanisms at the container level. A container can then have several folders and files under it. So the next unit of organization is folder or directory, which is yet another organizational unit. At this point, we are getting into more analytic specific needs of, folders and files are more Hadoop file system compatible. And you also have fine-grained access control that you can apply at a folder or directory level in the form of POSIX cycles. And you can do that in the file level too. And finally, the last layer is a file, which actually holds the data that you want to read or write. So when you think about organizing your data, the best practice here is think about a semantic structure. A zonal approach usually works very well here. And then once you've decided on the structure, you can think about storing this data or zones as different storage accounts or different containers or different folders. There are various considerations that go into this approach. We have a guidance document that talks about this in greater detail. I'll go ahead and share a link to the guidance document at the end of the presentation. So do check that out for more guidance and details on this. Now, let's get to the next question, which is, how do you secure the data? Azure Data Lake Storage gives you a layered approach to security. At the very periphery, you have the perimeter or network security that controls what kind of traffic is even accepted by your data lake. The premise of this kind of security relies on your compute resources living behind a VNet. What is a VNet? Think about Azure VNets as a logical isolation of your own network within the larger Azure ecosystem. So the premise here is within the VNet, all your resources can communicate and talk to each other more securely than it would outside the VNet. A server's endpoint in Azure Data Lake Storage allows you to allow certain VNet traffic only to come and talk to your data lake. A private endpoint goes one step further, and what it does, it basically gives an address for your data lake, an IP address within the VNet. So your data lake storage appears as yet another resource within the VNet itself. Private endpoints are a more recommended solution for your network security. Next, we'll move on to authentication, which is the next layer in the ring. Authentication now says who is talking to your data lake. There are various forms of authentication that we support. One is Azure Active Directory based authentication, which we strongly recommend. Now, every application or every user has an identity in Azure Active Directory, and we tightly integrate with Azure Active Directory to understand who is talking to our system. And these Active Directory identities, which we call as security principles, can also be used to provide access to specific resources using one of the authorization principles that we'll talk about. Shared keys, think of this more as a connection string based approach where you don't have an idea of who it is, but as long as somebody has the shared key, and SAS tokens are similar to that as well, you'll be able to talk to the data lake storage. SAS tokens are capabilities that give you temporary access, short-lived access to the data lake depending on a token that we provide. Wherever possible for your analytics scenarios, we very strongly recommend that you use Azure Active Directory. And let's talk about authorization next. So authorization is giving access to specific resources within the data lake. So we have RBACs or role-based access control, where you can define roles or use one of our pre-existing roles to understand what kind a person who a user or an identity which is added to that role can do certain operations within that data lake. These operations could be management operations, such as setting up firewall rules or the encryption scheme, or it could be data operations, which is what kind of data they're allowed to read. Then we have POSIX ACLs, which are more fine-grained access controls that define access to specific folders and files within the storage account. And last but not the least, we have data protection itself, which is encryption of data both at rest and on the wire. Encryption of data at rest can be done in two ways. One, the default way is Microsoft generates a key and encrypts your data at rest. Or if you want to bring your own key, we support that with the customer managed keys features itself. Now let's take a look at authorization in a little bit more detail, because I do want to talk about a best practice here. So let's think about this organization Contoso.com. They have a storage account for their production data lake. And within that, they have taken our zonal approach that we talked about and organized the various zones into containers. And within the individual containers, they have organized the data further into folders, depending on what kind of business unit the data belongs to or the data is used by. Now, let's take a look at the storage account level. What we want to do is provide the data platform team essentially keys to the kingdom. So what you would do is you would create an AAD group called data platform admins, give it the role of a storage blob owner at the storage account level, and the individual users or application identities will be added to this AAD group. Next, let's say you have the data ingestion group, which is ingesting data into the raw data lake zone. What you would do is you would create a data ingestion AAD group, give it storage blob contributor permission so you can write data into the container. So the application identities or the user identities that are uploading data can write data into the raw container. Now, getting a little bit more fine-grained using ACLs, the way this would work is, let's say the finance team has an accounts folder that they want their accountants and accounting managers to have access to, both reading and writing. They would create a writer group for the accounts folder in AAD and give it an ACL of read, write, and execute at the account folder level. Now, if they want their individual accountants or accounting managers, they would go ahead and add them to AD groups. And when a partner team comes along that they want to give read access to, they would create a reader group and give partner teams access to the folder by adding them to the reader group that already has read and execute permissions. The usage of these AD groups is strongly recommended because it helps you just add any user to this group instead of going and managing adding the individual user at every folder or every file level. That could be more laborious, and let's say the user leaves the company, and at this point you will have to go and remove and keep track of all these ACLs as well. Instead, managing them at a group level gives you a much better control of access management. And we talked about how AAD is a recommended method of authentication. We also have ways where if you want an extra measure of security, we just announced a preview of disabling shared key-based authentication on your account if it's not needed. So quick recommendations: use VNets and VNet-based security controls for securing your network. Service or private endpoints are the capabilities, and private endpoints are strongly recommended. Use Azure Active Directory authentication to manage access. And you can use that, you can use 2 levels of access control: role-based access control for more coarse-grained access management at a storage account or a container level. And you also have POSIX ACLs for fine-grained access control at a file or a folder level. Use AAD groups to manage and group your identities and assign them to RBACs or ACLs. That will largely simplify your access management issues. Now let's get to the next section and final section of this designing your data lake part of the talk, which is how do you manage cost? Managing cost of your data lake can happen in 2 ways. One is choosing the right set of features and configurations. And second is controlling the amount of data that you have in the data lake and ensuring that the right data resides in the right place. So let's talk about the first one, choosing the right features. Azure Data Lake Storage or any other cloud resource or Azure resource for that matter is a platform that supports a wide variety of needs. We have a lot of capabilities that range from simple to advanced on a spectrum, and each of these have a cost versus a benefit associated with it. So when you are thinking about a data lake strategy, start with your requirements, identify the benefit that each of these features bring, and understand the cost that comes with it and make the right decision for your data lake. Let's take an example of our high availability disaster recovery offerings. We have a wide variety of redundancy options that we offer natively. So the simplest scheme is LRS or local redundancy, where we have 3 copies of your data within a single region. We have ZRS or zonal redundancy, where we still have the 3 copies of your data, but these 3 copies reside in different availability zones for better availability. And then we have geo redundancy, where in addition to the 3 copies of your data in one region, we also copy the data into another region. So when there is a disaster, you have a disaster recovery mechanism. Now, we recently introduced GZRS, which is a combination of geo as well as zonal redundancy. And as you can see, when you go from LRS all the way to GZRS, the cost gets higher and higher, but so do the capabilities. Putting that in perspective with your data lake, a GRS or a GZRS strategy might make great sense for your production environments where you are very focused on business continuity and your data, production data, is by design more important. Choosing a redundancy strategy, which is GRS or GZRS, makes more sense for your production environments versus for your lower environments, such as developer environments. You can probably choose a LRS strategy and have an automatic way to hydrate your data lake when you have to set it up for disaster recovery purposes. And this can lower your overall cost because you're not maintaining 6 copies of data all the time and paying for the duplicate copies of data as well if your data is not that critical. Now let's get into the second point, which is as your data continues to grow, and specifically there are specific zones of the data where you see this problem that are more heightened, You get into the situation of a data swamp where the central data team has not much visibility or control of what kind of data is contributing to that growth or how to manage the cost itself. Azure Data Lake Storage offers a set of features to help with this exact problem. And I told you that there are specific situations where this problem is specifically heightened. Remember the zones we talked about. Typically, what you see is the raw, enriched, and curated zones that I said are more planned activities. The data itself is much better controlled, but there is a possibility that the workspace zone can easily get out of control because these are scratch pads, and I know how I maintain my Outlook inbox, which is a disaster. So typically, a data developer or a data scientist could potentially let this workspace zone go out of control. And this could typically happen in your development environment also. In these cases, leverage our lifecycle management policies where Azure Data Lake Storage offers a tiered storage model. We have the hot, cool, and archive tiers. And when we are thinking about going down the tiers, the data at rest itself gets lower in terms of cost, and the transaction costs are higher. So when you know that you have data in your system that is typically not going to be highly transacted upon, think about moving that to a lower tier. An example here is some of these organizations have retention policies that all log files need to be stored for at least 5 years. A better tier for these log data that's most probably not going to be interacted, but they need to lie around for retention reasons is archive storage. And in addition, we also have automated policies to delete a certain data if it is of a certain age. So let's get to the same example of your blobs need to be retained for 5 years. You can set up retention policies that any data that's not modified for over 5 years can be automatically deleted. And that's another way to save your cost. So quick recap, when you think about lowering the cost of your data lake, think about choosing the right features for the right needs and use our lifecycle management policies to control your data and make sure that the right data, you're paying for the right tier for the right data. Now let's get into our final section of how you optimize your data lake for faster performance and scale. The goal here is as the businesses continue to invest more in the data lake and run more scenarios on the data lake, delivering the right performance and scale really become key. And performance and scale typically go hand in hand because optimizing for performance is essentially going to mean in the context of a storage system, you're going to optimize for IO patterns, and optimizing for these IO patterns essentially help you scale way better in terms of getting your IO profile right. You'll be able to scale way better. In addition to performance, it's also useful to think about what a scale unit is for your full data pipeline, which is both your compute and data resources. And as you scale and how you're planning to scale out, while optimizing for IO performance helps you scale up within a scale unit. So what are the basic considerations of these optimizations? First and foremost, you need to optimize for high throughput. The more data you get out of a single storage transaction, the better your overall performance is going to be. The target here is target at least a few MBs. Typically 100 MB is the rule of thumb, but you can go higher and it's even better. And second of all, optimize for data access patterns, especially when you're thinking about it in your query layer. The more you reduce unnecessary scanning of files and the more you think about reading only the data that you want to read, the better your performance is going to be, especially combined with the high throughput. And when you're thinking about writing data into the data lake, think about optimizing it for what kind of queries or reads is going to happen on this data. Now let's see a few considerations that help you optimize for these considerations of both throughput and data access patterns. The first and foremost is looking at the right file sizes and file formats. Too many small files can adversely impact your performance. Why is that? When you're thinking about a file, you are automatically incurring an overhead for reading every file with doing the appropriate metadata operations, such as checking for the right access. not just for the file, but throughout the hierarchy. And what you want to maximize for is lowering this overhead by reading as much data as you can from a single file transaction. And this gets to be a issue where you have too many small files, where you have to do too many metadata operations. And in addition, this also adversely impacts your throughput because you get much smaller throughput if you have too many small files, really small files. Excuse me. In addition to the file size, choosing the right format also can really help you with better performance and in addition, lower your cost. I want to do a special call out here for Parquet. That's one of the most popular file formats that's natively integrated into some of our analytics offerings. Excuse me. And here, what is Parquet? Parquet is a highly optimized columnar format. A Parquet file is organized into row groups that have, and every row group has column groups inside it. And every column group has the data pages with the actual data. So what you're optimizing here for is retrieving columnar data that is in terms of what kind of columns you get and also identifying what kind of columnar data governs the retrieval patterns. And I want to call out a customer story here where we worked on a very large customer who had the right set of organizational principles in terms of identifying the right Parquet files and ensuring that they're getting the right throughput out of their IOs. They were targeting a few hundred MBs, which was perfect. And what we saw was their performance was still really bad. And when we looked at it, they were having tens of thousands of IO operations to get the data that they want. And on further analysis, what we saw was while their throughput itself was good, they had too many row groups and the data size was, the throughput was good because they had hundreds of columns in their files. So in this particular case, by tweaking the format of this Parquet file to have a smaller number of row groups, what we were able to do is read even more data with their IOs and lower their IOs from tens of thousands to thousands of IOs for their needs. And they are still running great for a few months now with this optimized IO patterns. So quick recommendations, right? How do you get to the right file size and format? The first way to think about it is when you are ingesting files into the data lake, you can modify the sources to ingest larger files. That's golden. If for some reason you cannot do that, at that point, think about coalescing these multiple small files into one large file as one of the stages of your analytics processing. So typically data that's read multiple times, this coalescing layer is going to give you the guarantee that you're reading large files, getting more throughput, and also reducing the file overhead. And using file formats such as Parquet, because the data itself is stored in a highly optimized format, in addition to faster performance, this also lends itself to very high compression, lowering the overall cost of your data storage needs as well. And when you're looking at a real-time analytics pipeline, think about a micro-batching layer that aggregates the data, and some of our real-time analytics pipeline offerings such as Azure Stream Analytics or Databricks with Spark Streaming help with these scenarios as well, where you micro-batch data into larger writes. Let's get into the second category of optimization, where you are partitioning your data for optimized access. So remember we talked about optimization where you're getting access to only the data you need and you're avoiding unnecessary scanning of files. Nailing your partitioning strategy can really help with that. Let's take an example here where you have data coming in from various sensors and each sensor is sending temperature, humidity, or pressure values every hour. There are different partitioning schemes that you can use, and it totally depends on your query pattern. So an example is if you want to look for device health, if the device is doing all right, one way to organize this data is by sensor. If you want to look at how the weather has been over a given time, then organizing by time and having your sensor and metrics under that is a fine data partitioning strategy. If you want to look at how a particular metric has been trending across a certain time period, and at this point, organizing by metric layer is a good partitioning strategy. Now, think about a scenario where your scenario is querying for weather patterns over a particular period in time, and you have used a partitioning strategy that is by sensor ID. At this point, you would have to go query the year and month value for every sensor folder, thereby having a more unoptimized data calling pattern. In fact, so looking at your data partitioning in line with your query patterns is a very, very important part of your optimization. We had this story with another customer where they had a multi-petabyte data processing pipeline. And what they ended up doing was they had a partitioning strategy that was too fine-grained. So they had tens of thousands of partitions depending on a finer grained combination of values of their data. I'm just going to make an example here. So let's say that your data partitioning is done based on every hour of your data arrival. And your query patterns are looking for years or months worth of data. At this point, you're going and querying every hourly folders to go get the data that you want, and reducing this partitioning strategy to a month level, reduce the number of partitions from tens of thousands to 100, thereby optimizing for some of these query patterns as well. And jobs that used to take hours to run finished easily within an hour. So when you are looking at data partitioning, tread with care and make sure that your partitioning strategy aligns with your query schemes. Now, given this very recurrent theme of filtering for the right kind of data and getting only the data that you want, we have a feature in Azure Data Lake Storage where all this can be done at the storage layer itself. So that feature is what we call as query acceleration. It works on structured data, and you are able to specify a set of filtering criteria to get only the data that you want right in the storage layer. Think of this as in the context of a specific SQL statement. So with query acceleration, you're able to do what we call as column projections, where you're able to specify specific columns like you would in the select statement. And in addition, you're able to specify filtering criteria, which is, think of this as where clause in a SQL statement. So in addition to the data that you want to retrieve, you would be specifying a filtering criteria as well. And we run that filtering criteria right inside the storage layer and give you only the data that you want. This vastly optimizes your performance. And this also brings down your lower cost, overall cost, because otherwise you would have to spin up a compute layer, load all the data, and do the filtering in the compute layer. So you're saving on the compute cost as well, in addition to just optimizing for storage patterns. So the last point I want to leave with you in this section is, in some cases, it is very valid to pay for a premium feature that offers you faster performance, and that's totally valid. But in typical Hadoop or Spark-based analytics patterns, what we have observed is by optimizing your I/O patterns or your partitioning strategy or using features such as query acceleration, you're nailing the I/O pattern by optimizing only the data, by getting the data that you want, and also you're optimizing for higher throughput. In addition to faster performance and better scale, you would also be able to lower the overall cost of your data pipelines as well. That brings us to the end of this presentation. Thank you so much for listening to all our insights and guidance. I'm going to leave you with a set of resources. We have documentation on Azure Data Lake Storage, on Synapse Analytics, and essentially this content of this presentation, we have a guidance document that talks about all this in greater detail, and it lets you participate by either asking us questions or contributing to the document as well. So do check all these out and let us know if you have any questions. And otherwise, thank you so much for staying with us.